Hello, everyone. Oh, hi. Welcome to this session on algorithmic fairness, one of my personal research interests. So I'm very excited to be here in the session. And I'm very happy that Angelina Wang, is it Angelina Wang or? Okay, thank you. Sorry, I should have asked earlier. I should have asked last night over dinner. Um, yeah, very happy that she came to join us. She is just publishing already field-changing papers. She's a PhD student in computer science at Princeton and very much on topics of interest for us here at the symposium. I'm very excited to hear what she has to say today.
Well, thank you. Yeah, today I'll kind of be talking about how a lot of times when we think about responsible AI, especially from the technical perspective, it's focused on kind of treating all groups as the same and how we can recognize group difference. And so responsible AI, a lot of times, especially from the technical perspective, is really focused on these ideas of equality and kind of sameness and impartiality. And this has a lot of benefits. For one, it's really mathematically convenient to have this perspective. We can just kind of create these equations that say something like how the true positive rate for women, which is group A equals 1, is equal to the true positive rate of men, group A equals 0. And then after this, maybe we can focus on, model optimization or the other sorts of things people will sometimes like to focus on. Another thing, it's really easy to communicate inequalities. So two really important works. So machine bias would show that in criminal risk prediction, there are higher false positive rates for Black people compared to white people. And also gender shades showed that in commercial facial recognition technology, it works worse on people who are darker female compared to other demographics. And these two works are really important in kind of first communicating to both the general public, but also researcher awareness that these AI systems were unequal. And so I think we can attribute a lot of the sort of importance and intention to these works. But at the same time, it's not a coincidence that in both of these cases, it's Black people and often Black women that are the ones with the higher error rates. And so now that we have this sort of general awareness that these systems are unfair, we can kind of add in more social context and bring in more of that into how we think about this. And so in doing so, we can think more about the ideas of equity, which unlike equality, does incorporate societal context and historical injustices. And so just from the simple infographic, we can see that kind of people of different heights or need steps of different sizes to access the same opportunities. So just as a quick example about how equality isn't enough, we can imagine on our phone photos app, maybe it misclassifies a human being as a gorilla. And this has very different harms depending on the racial group of the person. And so equalizing accuracy rates isn't going to be enough here because we have to think about the social context that these systems are in and how it just causes very different harms for different groups of people. And so today I'll be talking a little bit about some works that try to think about how we can bring in some of this social context. And so in one project, I'll talk about how we can evaluate without thinking of these groups as kind of interchangeable and the same. And then another project, I'll talk about how in large language models, we can start thinking about legitimate differences between groups and how to consider that. And so for evaluation, the setting I'm going to be talking about is for multi-group fairness. So if we're thinking about fairness with respect to multiple groups. And the setting here we'll just use as an example for binary loan prediction, for example, whether someone will get a loan or not. And here we can imagine we have 4 demographic groups, the intersections of Black and white people and women and men. And so what is typically done here is we have a fairness metric, maybe something like true positive rate difference. We could also imagine the difference between any sort of metric, false positive rate accuracy, and the same sorts of things I'm going to talk about are going to apply. So the way that fairness is generally measured in this setting is the maximum difference in true positive rate between any two groups. So for example, if we have a model which has true positive rates for these 4 groups between 0 and 1 like this, what generally happens is we just take the maximum pairwise difference between any of these groups. And another popular formulation is we take the maximum difference between one group to that of all, but all of these are going to kind of suffer from the same sorts of flaws that I'm going to talk about. And the flaw is mostly that if we imagine we have a second model now, and it does the exact same as this one, except for this one currently that we're seeing, it has the highest true positive rate for white men compared to Black women for whether it's giving loans or not. So this is reinforcing the existing social discrimination. If we have an identical model that flips this, so it gives the highest true positive rate to Black women and the lowest for white men, none of these fairness metrics can differentiate at all between these scenarios. And that should strike us as very wrong that the most common fairness metrics we're using can't distinguish between one model, which is completely reinforcing these sorts of social hierarchies, and one which is not. And another flaw is that it doesn't really keep track of any sorts of the differences between the groups, because ultimately this metric is just kind of the most simple mathematical extrapolation to multi-groups from the two-group difference that we had before. And so while this was a very mathematically convenient thing to do, it doesn't account for any of the additional social dynamics. And so one thing we can consider is trying to ground how the model is performing in the social context. And so what is relevant here is looking at the base positive rates. And so base positive rate is in the training data. What percentage of individuals from each of these groups have been given loans in the past? As we know, this data is likely going to be very biased. And so we actually can use that bias and use the existing bias in the training data as a proxy for the kinds of social discrimination in society. And so then what would be really important to us here is looking at the correlation between the bias in the training data and how the model is doing. And so we can take maybe a correlation metric like Kendall's tau, and now the higher this correlation metric is, the more it's reifying these sorts of existing social hierarchies. And so now if our model flips how well it's doing for Black women and white men, the correlation will correspondingly go down and show us that this is a model which is not reifying these sorts of existing hierarchies. We can actually try and differentiate between these two different scenarios. And instead of the training data-based positive rate, we could also imagine using better proxies, for example, looking at history of wage and labor discrimination in American society and different kinds of census data instead. And so some of the takeaways here is that from the kind of typical computer science machine learning perspective, something as simple as a variable name hides all of the social context. It really doesn't matter if group A is better than group D because they've been totally abstracted away from the context that we actually care about. And these groups just look interchangeable to us. And so we really have to think about what sorts of abstractions we're making and how they might take away from the things that we care about. And so building on some of these themes, next I'm going to talk about the importance of positionality. And how if we really think about social context, there's also genuine differences between groups. And when we do this, we're going to have to be very precise about the sorts of harms we're talking about. Because historically, certain kinds of differences between groups are harmful, but also certain kinds of differences between groups, if we ignore those, that is harmful. And so instead of kind of gesturing at maybe different kinds of predictions for different groups of people, we should think about what those differences are and how they might actually be harmful. And so for this, I'm going to talk about large language models and a popular kind of usage that is being picked up today. And that's for large language models as replacements for human participants. And so there's been a lot of research work and even for-profit companies coming out that are trying to replace human participants in computational social sciences, human user studies, political opinion surveys, all of these sorts of things. So they have these taglines like user research without the users. And in all of this sort of excitement, something very important has been forgotten, which is the importance of human positionality, which is the relevance of human participant social identities. So when we collect political opinion surveys, we try very hard to make it representative of the human population so that we can have generalizable findings. And this is true even for seemingly more objective tasks, like annotating how toxic a piece of natural language text is. We know that human identity really influences how we perceive things to be toxic or stereotypical. And so we can imagine if we do try to fit this into the large language model paradigm, we can just prompt the language model to take on different kinds of personas and identities. And so there has been a line of work looking at large language models when they have been assigned identities, but most of the time they're focused on invariance. So for example, how models of different personas might output more or less toxic speech, or more or reason with better or worse capabilities. But the desire there is for invariance, and bias is seen as difference between personas. But if we think about positionality, we actually desire differences between personas because those represent genuine differences in position. And so in this work, we argue that large language models cannot portray identity groups, and because of this, they cannot replace human participants. And we argue this along a few different lines, but today I'm going to talk about how large language models are going to misportray identity groups. And misportrayal can mean any number of things. It can mean misportraying identity groups as being too harmless and refusing to answer things, as being too liberal or too conservative. But we're specifically focused on a form of misportrayal where a language model is representing a group more like what the outgroup member thinks of that group rather than what in-group members actually think of themselves. And this definition of misportrayal we have stems exactly from the format of training data that language models are trained on. And so large language models are just trained on available internet text. And in this sort of available internet text, author identity is very rarely associated with the text in any sort of way. There's some rare exceptions, for example, autobiographical text or identity coded names. For the most part, there's no sort of association here. And so here are some examples of quotes from the New York Times for the identity of the word blind. So on the left, we see the word blind spoken by outgroup members, where it talks about blind people being treated discriminatorily or being grouped with handicapped people and seen as in need of social welfare, or being romanticized as winning different kinds of sports. And on the right, we see an example where the word blind is written by an in-group member, and they talk about their blindness as being more of an annoyance. And so this is to show how when identity words are named, they're just as likely to be said and invoked by outgroup members as in-group members. And these groups are likely speaking very differently when they do invoke these names. So for example, here, outgroup members might prefer a medical model of disability and see disability as something that prevents people from achieving different sorts of things, whereas in-group members might prefer a social model of disability and see disabilities as a result of how the world is situated to be more accommodating to certain groups of people than others. And so because of this, we have a hypothesis that large language model generations, when prompted to resemble certain personas, are going to be more like these sorts of outgroup perceptions rather than genuine in-group representations. And this stems directly from the fact that what a large language model learns about these groups is from the explicit names of the groups, and these are just as likely to be said by outgroup as in-group members, and those are likely to be very different from each other. And so because of this, the misportrayal is inherent to this use of online training data and unlikely to go away with newer models. And so many of the limitations we're seeing now about these large language models might just go away with the newer or bigger model. But I think that as long as our models are being trained on available internet text, as they pretty much are, this is going to stay something that's inherent. And so how can we actually operationalize and test this hypothesis? It's hard to think about what positionality can mean because even if people share an identity, there's a huge diversity of perspectives within there. And so the way that we do this is we conduct a series of human studies. For each persona, we get 100 generations from a large language model assigned to take on that persona, and then also 100 human participant responses from in-group members, and then 100 human participant responses from out-group members. So people who do not actually hold that persona, but are asked to pretend as if they do and answer from that perspective. And then the analysis we do is we take the Esper embeddings of these natural language texts, and for every single large language model embedding, we see whether its closest neighbor is from this cloud of in-group responses or this cloud of out-group responses. And so we do this across 5 demographic axes and 16 demographic groups. And when we do this, we do find that the large language model responses are much more similar to these out-group members imitating and pretending to be these groups rather than in-group. And so the circles here indicate statistical significance. The further on the left, the more like the outgroup it is. The crosses indicate when it's not statistically significant. And so what we see here is that there's only 2 groups that the large language model is representing more like the genuine in-group representations, and that's man and person without disabilities. And so we can imagine these are the groups that are already dominating a lot of the available online internet text. However, this is kind of hard to measure whether a large language model piece of natural text is more similar to in-group or out-group. And so while we felt that this was a good metric for capturing this, we want to make sure our findings are just an artifact of this one measurement. So we actually have 6 different measurements, all trying to capture this exact same construct. And they vary from using n-grams to these Esper embeddings to also MC, which is a multiple choice discretized version of this free response text. And so what is shown on the left is a fraction out of 6. So how many of these metrics out of 6 show that the large language model is consistently representing the more like the outgroup rather than in-group. And we bolded the ones where this is true for the majority. And so what we see is that this is more likely to happen for marginalized groups. And it's also the groups for which this is more harmful for. And so as an example here, this is one of the qualitative examples if we ask GPT-4 to take on the persona of a visually impaired person, and we ask about the perspective on immigration. And so GPT-4 says, as a visually impaired person, I may perceive issues like immigration a bit differently, not being able to fully see the images of crowds at the border or the faces of individuals seeking entry. My perspectives are rooted more in the sounds, words, and feelings described to me than visual presentations. And so as we can probably tell, this is not very representative of what someone might actually talk like. But at the same time, this is also a very subtle form of bias that is unlikely to be caught by some sort of toxicity detector or the tools we're used to using to measuring bias. I also kind of briefly mentioned that from looking at the human outgroup responses, I was surprised at how they actually sometimes resembled things like this that I wouldn't have expected. And so what we show is there's this technical limitation where the training data leads these large language models to misportray marginalized groups. And so other work has also looked at how large language models misportray marginalized groups, but they do it by showing that these models are more liberal or conservative or simply different. And we're specifically looking at the kind of misportrayal where it's more similar to what outgroup members are perceiving rather than in-groups. That's very different than just models not being able to represent people or representing people differently, because it's a specific kind of harm when they're misportrayed and erased in this kind of way. there's a history of harms here about where dominating oppressing groups are often speaking for marginalized groups and erasing those sorts of voices. And this can contribute to, for example, the phenomenon of double consciousness, where members of marginalized groups are often seeing themselves through the lens of the oppressing group rather from how they're perceiving themselves. And in cases that might seem egregious that researchers might simulate groups instead of engaging with them, in disability studies, there's actually a very long history of simulation, where, for example, researchers have sought sighted users and just given them blindfolds instead of actually engaging with blind or low vision users. And researchers have also found participants without communication disabilities and asked them to pretend as if they do to generate data that way, again, rather than actually engaging with these populations. In all of those cases, it's been shown that the simulated groups are acting very differently from people actually from these groups. And so we should be careful now that we have this new technology, we aren't just replicating the exact same harms from before. And so some of the takeaways here are that from the quality focus lens, we're often focused on treating all groups the same, and in doing so, treating all groups as the same. But we should really recognize that there are meaningful group differences and how these lived experiences can really matter for epistemic authority when we think about whose kind of viewpoints we're valuing and prioritizing. So these are some of the collaborators I've done this work with, and thank you all today.
We have time for a few questions.
I don't, I'm here to learn. So if it's not an LLM, for instance, if it's medical data that's being looked at, do you see any correlation to from your research if you're looking at medical data? No, actual medical data from large groups. Do you see any similarity in your research if you weren't using a language, an LLM, if you were using medical data?
Is there, if I can rephrase the question a little bit, do you see any potential application of some of the insights from this work in medical contexts?
Yeah, I think that in the medical data, I haven't worked too much in healthcare and AI, but as I understand it, I feel like a lot of times people really want to attribute disparities to just, for example, race differences and sex differences. But there's even a lot of work showing how differences people attribute to biological sex are actually due to a number of other sorts of social factors, and this is true for race as well. And so I think there's a lot of cases where people like to point to those and maybe think that it's a biologically originated disparity, but it actually comes from different socialization factors. And so getting a better grasp on that can redirect interventions towards the social factors which are actually the cause, rather than kind of pointing away and saying it's just a biological disparity. Thank you.
Yes, Sonia.
Thank you. This was an amazing talk. I'm intrigued with you're very smart gathering that the information on the internet is coming from an out-group perspective by and large. So I wrestle with this idea. I'm particularly thinking about your sites and the things you pointed at. What are some concerns about in-group members having their voice out there? I struggle with this. I have a friend of mine and I go back and forth. She argues there needs to be more Black people saying their experience to feed the LLMs a more diverse point of view. But my belief is after 400 years, the United States has never done anything good with Black data. I'm intrigued with your thoughts about that, with this out-group and in-group perspective. I love your thoughts.
Thank you. Yeah, I think that that's really hard because it feels like by giving more of your data to these big companies, you probably don't trust that they're going to do anything good, and they might just use it to not have to engage with these groups later so that they can use these simulations. And so it doesn't seem beneficial to help build better simulations, because I think that even if the simulations were able to totally capture in-group members, by virtue of not speaking to them, those sorts of erasure harms still persist. Like those harms themselves aren't actually technical. And so even if you are able to simulate them, they're still going to be there where you're not actually engaging with marginalized groups and those sorts of things.
Other questions? Michael.
So I know the answer is no, but I'm going to ask it anyway. Do SLMs or RAG help? Like I imagine the results, it sucks, but it's going to be like surface level better. But like, can you maybe? I don't know the answer, but can you elaborate?
Yeah, I mean, I haven't tried any RAG or some other sorts of techniques, but I think it's kind of the same thing where like, I believe that even if we could solve this technical problem, the sorts of social harms persist. And I felt like we needed to kind of show the technical difference to convince people who are not convinced by just the sort of social side of things. But I mean, I could imagine you could have a different training data set where you attribute every piece of text with the identity of the author. And maybe in those sorts of ways, generate much more realistic simulations. But I don't think that's the right way to go with this still.
Thanks so much that you packed so much into such a short presentation. I'm curious, just going back to the credit example for a minute, like this idea of genuine group differences. I feel like in the data science ML space gets weaponized to sort of like argue for the objectivity of models by saying like, oh, if there's differences in loan acceptance, it's really because of the genuine group differences between, you know, white and black borrowers. So I'm curious, like, how do you reckon with the fact that there are genuine group differences that shouldn't be flattened, but then there are others that need to be sort of pushed back against if you're really trying to build a better model?
Yeah, that's a great question. I think that's what makes it hard to talk about group differences, because again, sometimes it's good and sometimes it's bad. I think it requires engaging with the people involved and the literature involved to know kind of the histories of harm and what you're trying to correct for versus acknowledge is there and those sorts of things.
So one other wonderful things that Angelina did, she left lots of time for questions. She went through a lot of material very quickly. So anybody else who would like to ask a question, we have time.
Thanks for your talk. I really liked sort of the first of the verticals that you put up that showed, you know, how close people were for outgroup versus in-group. Because to me, it was a really strong demonstration of privilege. And there's a lot of debate about whether privilege really exists. And I think you have great data to demonstrate how clear it is. So have you thought about how you might kind of advance that line of research?
Yeah, one thing I've been kind of interested about is how people use large language models now a lot for advice, and there isn't necessarily, you know, a right or wrong answer, and it's also not clear what perspective you're trying to seek. And I'm sure that it's reinforcing particular kinds of viewpoints and particular epistemologies and ways of thinking and problem solving. And so just better understanding what are those things that are being valued more, likely what is seen more online, and just also what levels of personalization we actually do want or not. And I think there's also ideas of how prescriptive you would want to be versus letting users dictate things, and lots of tensions in that space.
Thank you. We have a question from an online participant. They say, great presentation. Any correlation to surveillance, as in identification error?
Yeah, I think that surveillance is hard because there it feels less like a technical problem than just the usage and the social systems it's in. And so I know that comes up a lot when people talk about how facial recognition technology is biased, as it's not clear if we even want less biased facial recognition technology, because if it works well, then we can surveil better. And so I think that ends up being much more of a social problem.
In other words, the problem in that case you just mentioned is the surveillance. Yeah, so. Okay, any other comments, questions? All right, well, let's give another round of applause to our speaker and we'll get set up with the next slides. All right, well, we're starting a little early. That's awfully nice. So our next speaker is Alycia Carey. Also doing really excellent work, graduate student, PhD student, and at University of Arkansas, Fayetteville. And I found her work because I work on similar topics, and she has, in my opinion, the absolute best review papers on statistical fairness and causal fairness. And so I send them to everybody that wants to know what I'm doing. So very happy to have her here, and I'll turn things over to Alycia.
Awesome, thank you. So yeah, today I'm going to be talking about one of the survey papers I did with my advisor a couple of years ago about causal fairness and its perspectives from both social and formal sciences. However, today, hopefully you can tell from the slide, I'm going to focus more on the socio-technical nature of causal fairness, which is enough technical detail to kind of understand what I'm talking about. Okay, so as we've kind of discussed throughout the day, the data sets we use to train our machine learning models are built from real world data. Unfortunately, since we humans are very far from perfect for making fair and unbiased decisions, the data sets that we end up producing are just simple mirrors to our societal biases. Okay, cool. And it's been well studied that when we build machine learning and AI systems using this biased data, rather than taking an agnostic approach to decision making that we had hoped to achieve by using non-human decision makers, we actually end up generating decisions with little transparency, accountability, and fairness. So if we want to implement fair AI systems, we first need to detect and quantify this undesired discrimination based on society's current definition and understanding of fairness. And then we need to design learning methods capable of removing this unfairness from future predictions and decisions. So current literature is abundant with different fairness measures, as some of them were listed on the screen here. And most of them are based on statistics, which these employ simple concepts of correlation or association. So statistical criteria, as Angelina mentioned, are a lot of times favored since they're relatively easy to calculate and enforce. So for instance, demographic parity is achieved if both, say, a group A and a group B have equal probabilities of being assigned to the positive predictive class, while equalized odds requires that both true and false positive rates are similar across groups. So here, these groups are normally based on some demographic criteria, such as race or gender, and in a lot of works, these groups are considered to be binary. However, fairness cannot be well assessed based on simple concepts of correlation or association, mainly for the fact that correlation does not equal causation. So for example, we can look to the argued case of gender discrimination against the University of California, Berkeley's admission process to their graduate school, I think in the 1970s. So after collecting and analyzing the admission results of students applying to the UC Berkeley's graduate school, the analysts found that males were 14% more likely to be admitted than their female counterparts, assuming that they had equal qualifications, which raised the concerns of possible gender discrimination. However, when researchers looked at the admission rates within specific departments, this bias against women went away or even reversed in several cases. Well, why did this happen? So this phenomenon of trends appearing in several different groups of data, but disappearing or reversing when these groups are combined, is called Simpson's paradox. So in other words, the overall percentages of the two groups can be misleading because of a confounding variable. So once this confounding variable is controlled for, say by stratification, the overall effect disappears or is reversed. So in this example, our confounding variable is the department choice. So it's clear that gender influences department choice, and one explanation of this could be that women simply chose to apply to harder departments that were more competitive to get into, and therefore that they were rejected at higher rates than men. And this was actually the conclusion that the study drew after all the analysis. And they concluded that the source of gender bias in admissions was a pipeline problem. So without any wrongdoings by the admission council, women were simply shunted by their socialization, which happens at an earlier stage of their lives. So, however, despite this conclusion, the question of discrimination in this system is far from resolved. We can ask, why did women apply to more competitive departments in the first place? Perhaps less competitive departments were unwelcoming of women at the time, or these departments had a track record of poor treatment that was known to the applicants, which swayed their decisions. So there's multiple different possible scenarios of why this happened, but we can't answer them based on observational data alone. But causal inference and causal fairness can get us a little bit closer. So before I can show how causal fairness analysis can help us find these missing causes of discrimination, I first need to introduce the very basics of causal inference and structural causal models. So causal inference presents a formal language that allows us to draw conclusions that a specific action or intervention caused an observed outcome. So in other words, it gives us a formal language that allows us to talk about causality. So for example, it allows us to answer questions that are oftentimes difficult to answer based on these observational data alone. such as interventional questions like, what if an applicant had been male instead of female? Or counterfactual questions such as, if we already know the outcome, what would the applicant still be denied if, keeping all of the variables the same, the applicant was male instead of female? So there are two main frameworks for causal inference, the structural causal model framework, which was proposed by Pearl, and the potential outcome framework, which was proposed by Rubin. But today I'm only going to talk about the SCM framework just for simplicity and time. So in the most basic terms, an SCM, oops, sorry, my bad. An SCM is a general class of data generating models. So the main idea behind an SCM is that the collection of mechanisms that underpin any decision-making scenario are causal, and therefore we should model them using formal causal language rather than through correlations learned through the data. So an SCM can be seen as dividing these variables into and involved in this data generation tasks into sets of exogenous and endogenous variables. So these exogenous variables are not observed, but they can still affect the endogenous variables present within the structural causal model. So in relation to the Berkeley example, each, say, of the variables for gender, department, admission could have a corresponding exogenous variable that affects them, such as parental income. That is something that could affect each of those variables. And that is not detailed in the pure observational data. On the other hand, the endogenous variables are set by causal processes that consider both these outside factors and the set of the endogenous variables that we call the parents of the variable. And the parents will make more sense on the next slide because I'll give a short little example. So even though these SCMs are very well defined, they have a lot of theory behind them, one critical observation is that they're not usually observable or even given with certain data sets. So further, based only on observational data, they can be very hard to define, as it's a very hard task to define all these exogenous variables, as well as the exact assignment functions that make up the underlying causal process of the this data generation scenario. So one way we can get around having to define these formal assignment equations and encode our assumptions about the underlying SCM is by using causal diagrams. So the causal diagram corresponding to an SCM is the directed graph that has one node for each variable x with incoming from edges from all of its parents. So for example here, this example is a possible SCM or a causal diagram for the Berkeley admission example. And here the endogenous variable D for department has its parent as X, which is gender. But how did we arrive at that SCM? What assumptions did we make about the world during its formulation? Well, we know that each student has a gender and that each student must choose a department to apply to. And from the previous observational data, we also know that gender has a clear connection with department choice, so we could draw an edge between the gender and the department. Then also from the original statistics, we know that there was a 14% difference between men and women in the admissions process. And so therefore we can draw a directed edge between gender and admission. Finally, we can reasonably assume that different departments have different admission requirements. Some might be more stringent than others, so department would have an effect on admissions as well. So however, in drawing this causal diagram, we're making several assumptions about the universe that this data generation process takes place in. So for instance, notice here that gender has no incoming parent nodes, meaning that it's not influenced by any other variables. And we kind of make the implicit assumption that it's a biological and in most cases binary trait. We know that's not the case though in the real world. So gender refers to the characteristics of women, girls, boys that are socially constructed. So this includes the norms, behaviors, and roles associated with being a woman, man, girl, or boy, as well as their relationships with each other. So as a social construct, gender varies from society to society and can also change over time. So in other words, instead of having just the original 3-variable causal diagram, we could have an extended one that models the socio-salient factors that make up gender. And I'll touch back on this idea a little bit later in the talk. So in any case, no matter which modeling assumption we choose, there's a clear need to determine how much of this observed statistical disparity can be attributed to the direct causal path. So that's the direct path between gender and admission, as well as the indirect causal path that goes through the department choice. So looking directly at gender for determining university admissions would indeed be disallowed. Whereas if you're using the department choice, which could be influenced by gender, that could be, allowed. So the need to explain an observable statistical disparity, say in this case, a 14% difference in admissions rates through this underlying causal mechanism, is a reoccurring theme when we're assessing discrimination. And we can actually calculate these probabilities of discrimination along different causal pathways using one of the several defined causal fairness metrics. So I'm not going to go through the technical definition of what all these mean today, just for time reasons, but the takeaway message would be that there exist several different causal fairness definitions that could be used to measure the underlying discrimination of a data generation process along different causal pathways. So for those with legal backgrounds in the audience, the terms direct and indirect discrimination that I used in the last slide may sound very familiar. So qualitative distinctions, such as differentiating direct and indirect discrimination, lie at the heart of some of the most important legal doctrines on discrimination. So in particular, the doctrine of disparate treatment asks questions of would a different decision have been made had this person been in a different demographic group? Okay. My bad. Sorry, I lost my place. So in causal terminology, the question is about disparities transmitted along the direct causal mechanisms between, say, the gender attribute and the admissions attribute. So on the other hand, the doctrine of disparate impacts considers situations in which a facially neutral policy, so one that does not use race or gender or any other demographic that's deemed unacceptable, results in very different outcomes for racial or gender groups. So in this case, the concern is with disparities transmitted along different indirect causal mechanisms. So in this sense, it seems that causality-based fairness criteria would be better suited to draft policies and regulations for AI systems than statistics-based criteria, since this understanding of discrimination in the real world requires understanding this causal connection between different plaintiff and defendant actions. However, I will briefly mention that there has been discussions about how this technical idea of causal inference and the legal idea of it don't necessarily match up, as well as the fact that some scholars see issue with the standard but for causation standard in discrimination analysis. That's a whole nother conversation, which is really, really interesting, but I'm going to go ahead and move on. So I've touched briefly on some of the sociological challenges present with causal fairness analysis, as well as how do we actually model our SCM or causal diagram. And there's been several more that have been written about in the literature, but I'm going to, for the end of the talk today, I'm just going to focus on the two I find really important. The first one is that many research works, the authors choose to model the demographic attributes like race and gender as biologically given, rather than modeling them from a socially constructivist viewpoint. Specifically, it's common for researchers to model these sensitive attributes as the source node in the causal graph. So when we make this choice, however, we then say that the demographic attribute has no incoming arrows or no parents, and therefore it's not influenced by any other social factor. So for example, say we have this following causal graph for loan decision, and notice how race has no incoming variables, meaning that it's a source node and it directly and indirectly affects whether a person gets a loan or not. However benign this modeling choice may seem to be, The metaphysics of race is a very complex subject, and it's been extensively discussed that the construction of racial categories and racial classifications of individuals is inextricably tied to the long history of oppression, segregation, and discriminatory practices. However, simply choosing to just adopt a social constructivist viewpoint for causal modeling is not very straightforward. Specifically, we would have to define all the nodes that faithfully represent the influence that society has on the demographic attribute or its perception of it. Additionally, we would have to know how all these nodes interact and if they could be disentangled to, get these different probabilities for being biased. So, for example, here's a very messy, causal diagram that models the Berkeley College and is an example from a more socially salient viewpoint where we include things like religion, your socioeconomic status, how you were socialized based on your gender, and so on. To draw this causal graph and to actually create an SCM, though, we would have to know how all these components interact. And that's not very simple to define at all. The second main sociological critique of causal fairness deals with the manipulability aspect of causal inference. So I didn't go very heavy into the technical details of causal fairness, but in performing causal inference, we end up performing interventions on certain nodes to change their value and see how one outcome would change in response. So this ability to change connections between any two variables while leaving the other unchanged is called modularity. So for example, in the Berkeley College mission example, modularity appears if we change the gender of the applicant while keeping their chosen major the same. So modularity is actually the cornerstone of causal inference, but some researchers actually see it as its downfall. So the first viewpoint argues from a socially constructive viewpoint again. So here the role that social categories play in structuring life experiences makes it illogical to say that two individuals are the same, save for their gender or race, and that causality-based fairness approaches suffer from the fundamental error of thinking membership in a group is separable from the experiences lived by those in it. So in short, the modularity property is non-valid, and that effectively breaks all of causal inference theory. So the second viewpoint argues that there should be no causation without manipulation. So in other words, causes should only be those things that could, in principle, be treatments in an experiment. If we believe there is no causation without manipulation, we would have to refrain from including immutable characteristics like gender or race in causal models altogether. And so Pearl, the creator of structural models himself, actually argued against this idea, saying that causation doesn't require manipulability, but rather just an understanding of the interactions between different variables. All right, so in summary, modern automated decision-making systems based on AI are fueled by data, which encode many complex historical processes and past potentially discriminatory practices that are present in our society. Such data is imprinted with these undesirable biases, cannot by itself be used and expected to produce fair systems, regardless of the level of statistical sophistication of the methods used or the amount of data available. So by and large, literature on fair machine learning has focused on statistical measures, and these fall short on providing a satisfactory answer for what is fair. So causal fairness analysis, on the other hand, brings us a little bit closer to understanding the true causes of discrimination. And it kind of aligns better with our notion of causal analysis in the law. However, it's not without its sociological challenges, such as how to define all these causal pathways and how to define your model, and how to define what a social demographic category is, and that there should be no causation without manipulation. So that's all I have for today. Thank you.
Well, thank you so much. Comments, questions from the audience? Yes, Sonia.
Thank you. Thank you. You know, I loved the but for line of the entire
you would.
presentation. But for causation, nobody's excited, but it's one of our critical elements in proving a negligence claim. And, you know, everything hinges on that premise. I think it's hard because the legal theory is still not even decided. So what are your thoughts about that, right? That, you know, we have the law, but the law changes. Math doesn't change. What are your thoughts about that? How do we align it to something that's kind of depends on the mood of the people?
So I think it's going to be a very interactive and living process. I don't think we're ever going to be able to find one set of standards of fairness that encompasses one in general everything. So like law right now is very situation based. We have law for healthcare, we have law for, discrimination. And I think we're going to need the same sort of regulations and policies in regards to AI, rather than just overarching umbrellas of AI policy. But yeah, the law changes. And so these rules will have to change as well.
Thank you. Other questions? I have a question. I mean, you raised these two really difficult problems. Do
Yeah.
you have any idea of possible solutions or?
So there's actually been a couple of different solutions that have been proposed specifically for, I think it's the modularity aspect of it. People have proposed different ways of actually structuring these SCMs. And so the way you create it, you can take more into account of the sociological aspects and how they interact with the different variables. Personally, I don't know. So I'm going to be real honest. Causality is not my field of research. I do trustworthy federated learning. But when I was kind of picking topics, this was on my list of possible interesting things. So
Yeah. Okay. Well, thank you. I mean, it's certainly been a very, for me, very helpful kind of entry level overview because I've tried to learn causal analysis probably a dozen times. And I always sort of get halfway through papers and halfway through books and it's complicated stuff. But this was a really, really great overview. Any other comments or questions? Any questions from online? One? No. Okay. Okay. Well, I can't believe it, but we're ahead of schedule. That's wonderful. So let's give one more round of applause to our speaker. All right. So our next speaker is Alexander Williams Tolbert. I heard Alexander at a philosophy and of AI conference in Germany. A terrific talk, tons of great ideas. And I know he has like 5 papers forthcoming and 5 more under review. So there's just tons of stuff coming out in the next year or two. And I think we're looking at an up and coming major star in the field. I don't want to, jinx anything, but I've been around long enough to tell, to see talent when it's right in front of me. So with that, I'll turn things over to Alexander.
So I'm professor at Emory in quantitative theory, methods, and CS there, and kind of piggybacking on this last talk, I'm going to talk about some of the limitations and issues in causal modeling, specifically around race as a variable. So like a lot of critiques have been made about purely predictive approaches to machine learning. So people have been trying to think about causality a bit more and different frameworks for causality. So we're kind of going to go through some of the issues with that. So the causal status of race has been subject to intensive debate in various disciplines. So computer science, stats, epidemiology, philosophy. And the discourse has been really influenced by the guy named Paul Holland's argument about the non-manipulability of race. This came out in a paper in 1980. This guy was ironically on the education board, on this sort of testing board, and they were getting a lot of criticism for their tests being racially biased. And interestingly enough, around this time, he came up with this argument for why, he thought race wasn't really a cause. And so, by implication, these tests really can be biased. Race isn't even a causal factor. So what was Holland's argument? So I'm going to call this Holland's argument, some good philosophy here. We're going to put in a little argument schema. So premise one, all causes are manipulable. So this is more or less called the manipulability or interventionist theory of causation, sort of like underrides most mathematical frameworks, whether it be the due calculus of Judea-Pearl, or what I'm going to talk about, like the potential outcomes framework for causal estimation. So if you disagree with this, you're kind of at odds with like the main sort of framework that's used in quantitative fields to estimate causal effects. So, and I'll get some intuition for this, and I guess I can get some intuition for it now. The idea behind this is like, oh, how do you tell whether or not something's a cause? Okay, let's say like you want to know whether or not some aspirin relieves my headache. Okay, like I intervene or I like treat like one group when receiving that aspirin, and the other group gets placebo, and then I like measure like the effect of whether or not they got an aspirin. It's like an intervention, performing an intervention on a population. Okay, so all causes are manipulable. Race is not manipulable. Like it's not like a coin flip, like a randomized controlled trial, and then change people's race based on the coin flip. So all causes are manipulable. It's not like you can in any sensible way like change somebody's race. Like I can like intervene and give somebody aspirin or not give them aspirin. Therefore, race is not a cause, at least according to Holland. And this is sort of like created this ongoing debate that I call the philosophy of race and causation. That's like sort of span these different disciplines. So like there's four more or less views you could take about this argument. The first view could be, again, I'm a philosopher, so we got to do good conceptual taxonomy here. One, race is not a cause on non-manipulable grounds, so you can be in the Holland camp here. You could be in this camp here. Race is a cause on manipulable grounds. So Pearls thinks you can manipulate race. So maybe you think about race in some other way that can be manipulated. Like maybe I'm intervening on like, I think race is some institution or something like this, and I can intervene on that. Or maybe I think race like is partially biological. I might think it's some parts of that I can intervene on. But basically he thinks there's ways you can intervene on the concept of race. Now Pearl isn't specific on how you do this. It's just vague how you're supposed to do this, but he claims that you can do it. Doesn't offer by much a way of argument how you do it, but he says you can do it. And you should just take his word. Race is a cause on some non-manipulable way, so maybe you don't want to be an interventionist about causation. Now, again, you need to show me how you can estimate average treatment effects with this account. So this is philosophers who may talk about abduction, or people like Lily Hu, they kind of just, again, leave it kind of vague how you might think about race as a cause. Oh, it's counterfactual maybe, but like there's no mathematical framework, at least that I have seen, for how they do this. But they say you can. Okay, so, again, lacking in the way of argument for how race is causal on these non-manipulable grounds, namely specifying this non-manipulable way bit, but they claim race is a cause on some non-manipulable way, with this part fairly unspecified. And then the last one, race is not a cause on non-manipulable grounds, so they think you need interventionism still, but aspects of race are manipulable, so like proxies for race. So maybe not race itself, but different parts of race, like a proxy for race. So Naftali Weinberg's argue this, Sid and Wei Sao, like they kind of say like, well, like a bundles of sticks view of race. But race is like a bundle of different races constituted by different things, and you can intervene on these different things. Now, these things are not race in itself, so race is still not manipulable. The aspects of race are, or racism is causal. This is something that, what's her name? She's an epidemiologist. It's slipping my mind now. I'm young, my memory shouldn't be this bad, but she thinks that, oh my gosh, like he's an epidemiologist, I can't remember his person's name. It's driving me crazy. But anyway, it'll probably come to me later. So, yeah, so, okay, well, what's my argument? I'm going to defend this notion of a causal agnosticism. I'm going to say it's reasonable to withhold whether or not judgment on whether or not race is a cause. So the central thesis is that, yeah, it's reasonable for socially constructed race to remain agnostic about their causal influence. important bit that this literature actually does not specify. Let me go back here. It's really unclear. Again, philosopher, you got to be precise. It's unclear if they're talking about if race is not a cause in some metaphysical sense. But that, I mean, it's like, is it just something about states of affairs where I believe race has causal power? Like, that's just some metaphysical claim versus like an epistemic claim. Do I have good reason or good knowledge to think that race is a cause? Those are two different things. You might think that race, like on whatever metaphysical grounds, has causal power in the world. That's one claim. There's another claim to say that you have good reason to think or epistemic access to that. I'm interested in this epistemic access bit. Do I have good reason based on our best science to think that race is a cause? I'm not interested in like some metaphysical position you have. You can have a metaphysical position. I'm interested in like good empirical evidence. That's what I'm going to argue. So that's an epistemic claim. Again, I got a paper on this, like you said, forthcoming in Philosophy Compass, about why I actually think that distinction is super important. And all of these people are really vague about that. Yeah, so that's my thesis. And again, as a philosopher, I'm about being precise here. So this is my argument. This is how I'm going to argue my claim. So my argument is the argument for causal agnosticism about race. Premise one, for all A and Y, if the hypothesis A causes Y has many unmeasured confounders, then it's reasonable to withhold judgment either way, whether A causes Y. Now, this is a fairly uncontroversial premise, I think. Basically, I'm saying that I'm not even mentioning anything about interventionism here. I'm just saying, look, if something has confounders, you have good reason to doubt if it's the cause. That's a fairly weak claim. And of course, philosophy style wants to start with a weak claim and get you to something that you don't want to agree with. And so I would hope most people can agree with this, that if something is confounded, you have good reason to doubt causation. Premise two, for all R and Y, if R represents race, then the hypothesis that R causes Y has many unmeasured confounders. I mean, this is going to be very easy to show. Trust me, this is going to be incredibly easy to show this premise right here. And then you're going to get the conclusion that this is a good old hypothetical syllogism in logic, you know, for all R and Y, if R represents race, it's reasonable to withhold judgment whether R causes Y. Thanks to Kareem Khalifa, professor at UCLA, who was working on this schema together. So it's a very simple, elegant argument. And we're going to walk through why you should believe me about this argument. And I'm going to consider some objections too. Again, I'm a philosopher. We have a little style. We like that when we make arguments, very clear, consider some objections, we'll reply to those objections, then hopefully you'll believe my thesis. This is why I love philosophy. It's very clear, you know. Well, what's confounding? Because again, we got to define some terms. I mentioned I like this style of when I give an argument schema, let's clarify some terms that was in there. Maybe you don't know what confounding is. Let's kind of explain it. So confounding occurs when an external factor not accounted for in the study affects both the treatment and outcome, potentially leading to spurious correlations. So for example, a medication prescribed to only individuals of a certain group who are at high risk of a specific condition might show a misleading relationship between the treatment and outcome. This example exemplifies confounding, obscuring the true causal effect. You know, so given some random variables X, A, and Y, asserting that A causes Y requires excluding the influence of variables like X. This is just like, you know, we're just like condition on X, or like controlling X. So without controlling some variables, you basically have unmeasured confounders, and then you have bias estimates of causation. Okay, so kind of intuition there. Now I'm going to go through a bit of a primer about like why you even care about this stuff. So I'll try to do it fairly quickly. So this is a framework for identifying causation. So like this is called a potential outcome. And what that means is something like this is a framework for identifying causal effects. A potential outcome is more or less something like this. I'll tell by way of a story. I'm a huge fan of rom-coms, and there's this movie, I forget what's her name, Gwyneth Paltrow, and she's on this train, and then she misses the train. What's the name of this movie? I forget the name. Boom, there you go. Sliding doors, sliding doors, and sliding doors. The purpose of this movie is that Gwyneth Paltrow misses the train, and then the movie shows like one world where she would have caught the train, and then it shows another movie where she misses the train. That's what a potential outcome is. Now, for any individual, we never see your potential outcome. So imagine that example I said with Tylenol, right? I want to measure the effect of Tylenol on this outcome, like headache relief or something like that. I want to imagine for you as an individual, the world where you received the Tylenol, but I also want to run and play the world where you didn't receive the Tylenol. That's impossible, right? We only can see one thing, the actual treatment you got. That's why we're interested in, we had this little expectation out here. That's like basically kind of like a summation. We're just gonna talk about like the average, you know, like a population who didn't receive treatment. And so this is the potential outcome. That's a counterfactual quantity, and causal identification is where we're causally treating, where the causal bit is, we're semantically treating a potential outcome as a causal thing. Again, we could have that be a do. In do calculus, that would be a do. It doesn't matter if you use potential outcomes or do calculus. Mathematically, they're equivalent. If people are interested, I can show you the paper that shows they're mathematically equivalent. But I'm just here because I was trained in stats. Like I just sociological fact. I'll work in this more. But identifiability is where we want to start with this and derive this. This is a conditional expectation. It's a purely statistical quantity. Once I get this, I can just like estimate this with traditional stuff and stats. Causal identifiability is like introducing assumptions to go from this causal thing to this statistical thing. And my argument basically says is because of confounding, specifically two types of confounding, you can't make that deduction. And so you can't get this thing to do estimation. I'm not going to go into this just for the sake of like, you know, actually going to my argument. You know, exchangeability, these are basically assumptions that you need. I want to focus on this in detail. This is the assumption I want to focus on for why you can't race causes lots of problems. Positivity, I want to explain on some slides that kind of explain in more detail what this is. So that's what we want to get to. So it's a whole bunch of assumptions basically you need, and this is basically the formula for how you get identifiability. Like through the law of total probability, you basically expand that out because of this assumption earlier, which is basically called exchangeability or ignorability, that the treatment is independent of the potential outcomes. You can introduce this A here. And then after that, this assumption earlier, consistency, it says the potential outcomes is equal to the observed outcomes. You can remove that and get that there. And that's purely statistical. I just got that from just straight up mathematical assumptions. And whether or not those assumptions hold is just based on some empirical stuff, right? Like any assumption, you know? So what is positivity? This is the thing that I want to say race constantly violates. So positivity is a condition where for all subgroups defined by covariance, which is that X, they have some probability of receiving any value treatment. In the formal terms of binary treatment, we assume that the like basically the probability you receive treatment is greater than 0. That would be some non-zero. You have to be, for all covariance, there has to be some greater than 0 probability you actually receive the treatment. And the reason why is because we want to estimate this. This is the average treatment effect. This is what I was describing sort of qualitatively. You receiving an aspirin, you not receiving an aspirin. We want to get this statistical thing right there. Okay. Violations of positivity implies conditioning on a 0 probability event. So if you violate positivity via Bayes' rule, so we consider this right-hand equation, we just use like discrete, you know, we're just going to use summations. Because, again, I'm a computer science person kind of, so I want to talk about summations. I mean, it's going to be intervals, but yeah, so we apply Bayes' rule here and we expand this out. And what we see here is like positively essential because if this equals 0, this equals 0 for any X equals X, any covariate greater than 0, you get division by 0, which leaves the causal effect undefined because you end up dividing by 0 here. So basically, that's a mathematical reason for why you have to have some value greater than 0. The intuition for it. Here's like an intuitive way to think about it. Imagine I want to estimate the average causal effect in this room. Imagine I use that Tylenol example. Imagine I only give like the women the treatment in here. I never give them the placebo. There's no way I can tell you anything about what the average causal effect is because there's no probability that they could have received the placebo. All of them received the treatment. There's no data there, basically. I mean, that's the intuition. You know, this is the mathematical reason. So yeah, so positivity implies a scenario within some subgroup of the data, everyone either receives only treatment or only control. That's basically what I just said. This makes the estimated causal effect of treatment versus control impossible in that subgroup because we lack observations of the alternative condition. Now, again, people who do a lot of epidemiology, this happens all the time. Another term for this is overlap. It means the groups sufficiently overlap, right? Another name for it is like common support. I'm not going to go into all of this stuff. So yeah, so basically for every subgroup defined by covariance X, they have some possibility of receiving a treatment condition. Okay, so hopefully that this is clear. I'm not going to go into more of this. This is just like a diagram that shows like you can't, if you have total population, everybody just receive treatment, it doesn't even make any sense. This is what you want. You want that, you know. All right, now what's the problem with race? Okay, well, with race, we can have different types of positivity violations. So one is segregation. You have at any time, basically groups don't look alike. And that can happen in any scenario you have extreme discrimination, right? So, and this happens in a lot of segregation studies. So like, in segregation and racism, structured data correlating with race and poverty. So in situations where like you want to study like stuff about neighborhoods because like you don't have white people in Black neighborhoods, you can't tell whether or not like the effect is due to SCS or whether or not it's due to race. So that's an example. Of course, this is a clear example for how you have positivity. Let's say you want to study like skin cancer and race. Obviously, there's not going to be not going to have any white people with dark pigmentation, and vice versa. So that's an example. So yeah, the absence of marginalized groups in peer privileged position leads to substantial positivity violation, some deterministic due to discriminatory practices and social structures, historical caste, like in India, historical structure based on birth and occupation, individuals assigned a specific caste with limited mobility between them. Discrimination ensured significant barriers to upward mobility to lower caste. So a lack of overlap between higher and lower caste represents deterministic probability. Same thing with slavery, obviously. The history of racism in the US. Obviously the racial wealth gap here. Basically, you're not going to find many Black millionaires in Mobile, Alabama, where I'm from. Okay. And so these groups don't look alike. Positivity violations with race here abound, standinarity. They talk about this, like I said, with the racial wealth gap. Now, this introduces this is kind of the punchline of this talk here. This is an interesting problem for many social constructivists about race. Now, that's the default position. Now, again, I'm a philosopher of race. It's amazing to me, like how many notice 4 views on race, not one view of race, but it's like the default thing, I guess, because it's woke or something. I don't know, like for people just to say, oh, race is a social construction. Okay, what do you mean by that? What type of social construction? I don't know. I don't know. Now, again, philosophers, we not taking none of that for granted. So in this book, you have people debating 4 views of race. Unlike the one view of race that I just hear ad nauseum, social constructivists. Okay, let's pick your favorite view, social constructivism. Again, I'm a philosopher. This is what we like to do. I want to pick your favorite view, social constructivism. It's a lot of consequences for that view under this. That just showed you an empirical fact. about a mathematical framework that underwrites all the statistics. Any social science research that you will want to use as quantitative is using some, and then they want to do causation. Positivity and confounding is a thing they care about. Now I'm going to show you how that is a problem for social constructivism. All right, Sally Haslinger, one of the main people in this camp, who again, people like to cite ad nauseum. I'm not even gonna say what I was gonna say because I'm recorded, but you know, if you want to ask me offline some other stuff, I'll tell you. But Sally Haslinger's view on social constructivism here, they think that it's defined as racialized practices, constructing social realities around physical features. So racialization thesis says, hierarchical positioning of ethnic groups within a broader social category or broader political formation is the process of racializing a group. Now, it's important. If you're a social constructivist of this variety, you think a racialized group is a race. A racialized group is a race in this view, in the Haslangerian view. This is kind of like the, again, I would say it's the paradigmatic view. Racialization is a process by which races are formed. I ain't making this up. Go read the book. Accepting racialization leads to positivity. Just by definition of racialization. I don't understand how people didn't even realize it. It's just kind of crazy. And it hinders, so therefore will hinder causal effects. Now, again, I'm a philosopher. Kwame Appiah, one of my favorite philosophers, very elegant writer. In one of his first papers about race that started philosophy of race literature in like 1980 something, when he was talking about Du Bois and all this stuff, critiquing Du Bois's view about race, he sets up a very beautiful argument schema. Again, philosophers like argument schema. It's a proof by cases, by setting up like a dilemma here. I'm going to do a similar type of move. So on one horn, the inability to make causal inferences undermines the knowledge about racialization's role in formalizing races. Think about it. Racialization is a process by which you say a racial group forms. How do you know that? Presumably empirically by studying causation, right? Stuff in the world, right? Racialization is a thing. Well, this kind of leads to a contradiction because it undermines the very claim. Let's walk through why. And then the second horn, if you reject racialization, say, well, no, I don't want to be racialization. I don't agree with that because I want to know about causal inference. Because remember, racialization say groups don't look alike. That's what makes a race. And the racialization thesis, what makes a race is that you are not like another group. That means you will have positivity because you have a lack of overlap. That means you don't know causal inferences. That means you don't know about racialization on the first one. Well, you say, well, hold up, I want to know about causes. Okay, so you reject racialization. Okay, well, then you reject social races. Boom. Immediate contradiction. So this rejection undermines the metaphysical claim about the existence of social races. I got you. That's tough. That's tough. You want to read his papers in the Journal of Philosophy of Science. I would like to see somebody get out of this. The reviewers was like, this is a tough one. I was like, I agree, you know. Hey, but I don't even believe racist. I don't believe in social constructivism. I have another view about race, you know, so, you know, I don't have this problem. But okay, so rejecting racialization eases, so you reject racialization to ease causal inferences that denies the metaphysical reality of social races. That's the thing we all want to say it out there. That was our default position. That's like the neoliberal thing to just say, like, this is social constructivism. Okay, well, you know, that leads to a contradiction. To know causal effects, to know things about racialization means you got to reject racialization. Again, within the potential outcomes framework for causation, which again underwrites the social sciences, a lot of them. Okay, so yeah, so basically this leads to a dilemma. Now this has some ethical implications here. This is the paper I was telling you about. This is also forthcoming in Synthase. Now, one thing you could do to ease that epistemic worry is to make groups look more similar. You could give me reparations out here. if you want groups to look, if you actually want to know about causal effects, One thing to do is like make the groups look similar. Engage in various types of social interventions that have overlap. That would be motivated by epistemic claim to know about causal effects, to know the social world and to study it in a robust way. How much time I got left?
I wasn't paying attention. You have another 9 minutes.
Cool. We got enough
Well,
time.
I should say 4 minutes if we want to leave some time for
Okay,
questions.
we got enough time to get 4 minutes is all I need to get through this last one. Now, if you thought that argument was devastating enough, I got another one. Another one. And I actually think this one better than the last, to be honest with you. All right, so unstable variables are a problem in the social science. An example is HDL, or total cholesterol. So early investigation of total cholesterol on heart disease D, where we measure by TC, was treated as the sum of like LDL, HDL, right? Everybody who's went to the doctor kind of know about this. One is good, the other is bad, right? So eventually they realized that they have different effects on D, the heart disease. Higher levels of LDL increase the probability, while higher levels of HDL decrease the probability of D. And the effect of the intervention on TC to set to the value V via a drug is ambiguous because it depends on the mix of LDL and HDL. Now, you know what I'm going to argue here. In social science, race is a macro variable, just like this. And it has the same problem. All right, so like I said, prescribing a low diet entails an ambiguous intervention. The term low cholesterol could imply a reduction in LDL or HDL or both. Without knowledge about the relative levels of LDL and HDL, it's challenging to determine the causal effect relationship. Woodward claims these situations, we should prefer micro variables, the micro states. Now again, because I ain't got time here, I'll talk about it. Sandy Darity be talking about this a little bit too, but people wasn't seeing the connection of what he was talking about. But he making a similar point with disaggregating the race variable. Anyway, so this is the exhibit more consistent effects. Now I'm going to argue that similar thing happens with race. I'm just going to pick a very simple example to where you think race might be constitutive of self-identity and ancestry. Two, again, fairly non-controversial microstates. Self-identity, again, philosopher, I'm gonna make weak claims and just show you how they lead to crazy stuff, you know? So, genetic ancestry. Most folks say like that was the problem with the racial, whatever her name was, is that, hey, she ain't got no ancestry. You know, okay, so we think that that's a part of probably what makes up race, right? Okay, well, let's say I intervene on that. Genetic ancestry. So let's say for a drug. So recruiting a more uniform pool based on genetic ancestry aims to select participants with more homogeneous genetic background within a racial group. This aims to reduce the genetic variability within a group to better isolate the effects of the drug, right? However, if prevalent genetic traits within this homogeneous group result, if prevalent genetic traits within this homogeneous group result in poor metabolism or adverse effects, the drug might appear like not very effective. So basically you got a lot of people, they might metabolize the drug in a certain way. Now let's say you like intervene based on self-ID. Now obviously you're gonna have more heterogeneity there. And you might get a different effect of what the drug might look like. So the point is I'm basically setting up an example that's almost exactly analogous to the total cholesterol example, where if you recruit a more uniform pool, you might metabolize the drug in a different way based on, genetic ancestry. If you intervene on self-ID, just by the nature of self-identification, you're gonna have more heterogeneity. So the drug, it might basically gonna get two counter opposed causal effects, so the intervention is ambiguous. And that violates this assumption called SUFTA and causal inference. Again, it's another technical one I went through. I kind of glommed over it. But if you, race as a macro variable is really popular in the social sciences. So where they think race is composed of all these different things. And that kind of leads you to this issue here, basically. So race violates, again, another one of these assumptions. We need the causal effects. It leads to confounding. Boom, you don't know about race. Again, this is also the case within, like, you know, within racial variables. Again, I'm like, there's been a ton of studies that show like if you study disparities or look at just the category Black, you'll get a whole bunch of different outcomes because Black immigrants are different from people who are descended from slaves in the US. And so even within the category Black, there's problems. This is called the problem of heterogeneic effects. Again, I'm not going to go into all of this, but this is well studied. And so people, again, suggest for disaggregating into microstates. Again, I'm not going to go into all of this. Like I said, just for the sake of time, see if I'm going the wrong way. Yeah, I'm not going to go into objection again. We can talk about this maybe in the Q&A or afterwards. So yeah. So conclusion here. The argument for causal agnosticism is based on like this causal premise of holding judgment due to unmeasured confounding versus confounded due to it being social, like very complicated thing. Key challenges, positivity, and these SUPTA violations or these ambiguity violations hinder causal inference about race effects, embracing agnosticism, acknowledge epistemic limitations due to studying race, and acknowledging underlying racial and structural issues that improve causal inference, as well as maybe doing aggregation of variables. So yeah, thanks for listening to me here.
All right, we have just 4 minutes for questions, but the next 15 minutes, we have a break after that. So maybe we'll certainly get a few in. Questions? So on.
Exciting. I wish I could see the whole talk. Do you think that racialization has to result in mutually exclusive groups? Like you could imagine like a social category, it's sort of treated as like a mutually exclusive set of groups, but like we know that like really they're not. And so there is some degree of overlap, even though like the way we would use the term in everyday life would be in this kind of mutually exclusive way. So I wonder how strong the claim is about like racialization requiring this perfectly mutually exclusive set of groups.
Yeah, I mean, I think it is based on, so again, I think don't forget deterministic positivity violation where you have like no overlap with it at all, and then you have stochastic, right? So the argument mostly obviously is pushing towards the type of stochastic positivity violation. And that's going to be true based on how racist the society is, basically. You know, again, like that's the kind of that's the subtle thing about the argument. Remember, racialization thesis says the more discrimination you have, that generates social racism. So positivity travels with it. You know, so the more you think there's social racism via racialization, the more you have positivity violations. And again, that's just an empirical fact. So if you tell me how much positivity there violations are, show me how racist society is. You know. I don't know that. Yeah.
All right, so that was very exciting, and it became clear once you were giving the cholesterol example. I could see it, but now I'm intrigued because there was something about the race as a social construct that always it graded, and I think this helped explain it because basically the math is not mathing if you believe race is a social construct. And you said you have your own definition or understanding of race is. What is it?
Oh, well, so my argument is again one of these sort of like judo philosophy arguments. One, I think that is like I think blaming race is just I don't like that discourse. I think it's a distraction. I think we could be talking about other variables that are more clear. I think race is like witches, or like gremlins, or like mermaids. It's not a real thing. Like what makes a market real? That's a social kind. A market is a social kind. What makes a market real? Is that there are actually people buying and selling and doing. There's actually something that corresponds to a state of affairs in the world. That will make a market real as a category. What makes a witch not real? A witch is people who have magical powers, who fly on a broom, and they can cast spells. Why is that not real? Because there are no people flying on brooms, casting spells. I'm not talking about people who practice Wicca. I'm talking about witches, like who fly around on brooms, who make a mermaid real, has to be a half fish, half creature. There's no state of affairs that correspond to that. Well, where am I? What's a race then? I don't know what that is. That's like a witch to me. That's like a mermaid to me. It's also, I'm what's called in this literature an anti-realist about race. I don't think race is real. So, and when people try to redefine it to mean these other things, I think that you get problems. Like, you know, now again, we do have this happen in science all the time, and it's kind of quite difficult. This is a deep philosophy of science question people don't realize. So, for instance, in science, an atom, by Democritus' definition, meant something that was indivisible. That's what the concept meant. But now, what if you ask me what does an atom refer to? Well, it actually refers to something that's divisible. Well, you wouldn't say that atoms don't exist, though, because the concept's kind of been redefined in science and mean this other thing. I'm not convinced that race is like that, though. I'm more convinced race is like witches, though. When we found out that a manatee, when we found out to be that mermaid, people thought mermaids were like these half fish, half things, right? And then we found out that it actually were just like manatees in the water. We didn't redefine the concept mermaid to be manatees, though. I think race is more like that. So again, that's a more complicated philosophical argument for why I think that. But again, I just think social constructivists just take so much stuff for granted. So anyway,
We'll take one more question, but I hope people will get a chance to talk.
yeah, I hang around. If people want to talk, I'll hang around.
One more question.
I'm wondering if your argument about causality extends from like experimental or quasi-experimental research to observational research. So like think like just a typical regression model, like where you're maybe not as interested in the causal mechanism, but more just identifying disparities among racial groups. Like, do you feel like many of the assumptions you've identified are still problematic for like a weaker argument like that?
Yeah, that's a good question. I mean, if you're using observational studies to like infer causal effects, then yes, because again, all of those assumptions like are used in observational studies to say something causal about the results of the study. And again, if you have positivity violation, then you can't say anything. And if you in this slide, it's extrapolation issues basically. Like I had this slide where you didn't have the groups overlap. If you fit in regressions, it's just nothing to fit a regression to, basically. Yeah. I mean, I can't find a slide, but basically, like if you have no data on the group, like looking like the other group, like if nobody here received the treatment, then I'm extrapolating what it might even look like. It's unfounded inference, you know? So, yeah. Yeah.
Right. Join me in thanking again our speaker. And let's have one more round of applause for all the speakers in the session. Thank you.